Riemann sums, named after this guy who, in my opinion, looks a lot like President James Garfield. Okay, and they lived at the same time. Of course, he died before Garfield was assassinated. But anyway, there's a lot going on here, a lot of life lessons. But I do want to talk about something that I will squeeze in that space. But in the meantime, let's just slide up. Approximate the area bound between the function, shown here, and the x-axis on the interval from 0 to 6 with three rectangles using a left-hand Riemann sum, a right-hand Riemann sum, and a midpoint Riemann sum. You don't even know what it is, and we're just going to do it, okay? So just do it. Just do it. Here's what's about to happen. Do you remember the terrifying balloon creature from the last notes? Rawr, eating people on the street. Remember that? Okay. This is a situation where we could not exactly figure out this area. Like we didn't know, so we had to estimate. We'd used diagonal lines, and in this case, we're going to use lots of rectangles. And I say lots of, in this case, just 3. It's a good place to start. So here's what we're going to do. We want to know the area bound between this function and the x-axis on this interval with 3 rectangles by using a left-hand Riemann sum, a right-hand Riemann sum, and a midpoint Riemann sum. I don't know where those sound effects came from, but I just had a lot of fun doing it. So here's 6, no surprises there. I have a question. We're going to use 3 rectangles, and I should say this too, of equal width. That should be in the directions. I apologize that it's not explicitly stated. If you're looking at this version of it, it might be updated in later versions. But anyway, 3 rectangles of equal width. And so this is where a formula is going to come from. The width of the rectangles. What do you mean rectangles? Okay, if I had to squeeze 3 things in here of equal width from 0 to 6, how wide would each one be? Okay, so I got to squeeze 3 things from here to here. How wide is each one? 2, right? Okay, because the distance is 6, we divide it by 3 and we get 2, and nobody is surprised. Nobody is surprised. So the width of rectangles is, all right, bear with me here. If I know the width of my interval, I can divide it by the number of rectangles. I've left the numerator blank intentionally. We're going to let this be the number of rectangles. Number of rectangles that we're dealing with. This is really a common sense formula once I write it. So how wide is my interval? 6, no big deal. If I would have said we're going to go on an interval from 1 to 5, how wide would that be? 4, okay? And then we do 4 divided by 3 and things get tricky because of the fraction, but whatever. But if it was from 1 to 5, the width would be 4. If it was from 2 to 5, the width would be 3. The interval length, I should say, would be 3. If you want to know how wide your interval is, do big number minus little number. And so here goes. Usually intervals go from B to A. So this is the interval from A to B. A to B, I should say, not B to A. So subtract B minus A. That'll tell you how wide the entire interval is, then divide it up evenly in the number of rectangles. Kind of a common sense formula. We'll see where this comes in handy in a minute. All right, back to the problem at hand. 3 rectangles of equal width, I should say. And we are going to let each rectangle be 2 units wide, okay? And so I'm going to use a left-hand sum. Follow me closely. I'm going to use this ink pen instead. And I will start on the lefty left of this interval, which is at 0. And I'm going to draw this. I'm going to go up from 0 until I hit the function, and then I'm just going to stop and hold my pen there and say, I'm done with the height of my rectangle. Now let's move over 2 units. That, my friends, is my first rectangle. What are you going to do with that rectangle? Well, in just a minute, I am going to, wait for it, find this area, and then I'm going to do another rectangle, and I'm going to add those together, and that will be an approximation, maybe a terrible approximation, but an approximation of this area right here. Lovely, isn't it? Okay, so highlighter, because I can. I wanted to find this area right here. So this area, which will be my blue rectangle, written in blue. How wide is it? It's 2 wide. How high is it? Now you could be like, oh, it's a 1, 2, 3, 4, 5, 8, which we can kind of get from there. And you'd be right to say that it is 8 units high. You are not wrong. However, what I'm going to do is I'm going to say that it is this high. Because that is the number that determined the 8, right? Because in just a minute, I'm going to switch colors very demonstratively. And I'm going to go to my second rectangle, which I will let be red, orange. So I am moving over 1, and I'm going to start here. I say one rectangle, and I'm going to draw this rectangle right here. And I'm going to go up until I hit the function, done. And I'm going to move over the width of a rectangle, 2 units. And I'm going to color it orange. So my second rectangle is how wide? 2. And how tall is it? I don't know. But I found out the height of my rectangle from f of 2. F of 2. All right, let's do the next one. It'll be green. So up until we hit the function, and then go over 2, and then down. And I'm going to highlight that one. It's for fun. There we go. And we will have a width of 2. And what was the height of this function? The height of this rectangle? Well, the height of the rectangle was determined by the value of the function at 1, 2, 3, 4 to f of 4. Okay, we're going to figure that out. So give me just a moment. And I actually need to plug up my phone. It's recording and it's about to die. So here's what we're about to do. We're going to plug that into the calculator. Actually, let me write the next step before I go grab that little battery pack. 2, notice you can factor a 2 out of these. F of 0 plus f of 2 plus f of 4. And as I go grab what I'm about to grab, then I recommend that you start typing the function into your calculator. Be right back. Been recording videos for so long. Even my mama thinks that my mind is gone. It's a song. All right, so negative 1/8. There, aren't you glad you know that now? 1/8 is 0.125. X squared plus 8. I like to, instead of squared, I just like to put XX. And here's what I'm about to do. Check it out, check it out, check it out, out. I could find those exact values. I'm not. I could find the exact values and then like proceed with the process having written them down. I'm not going to do that. What I am going to do, however, is this is equal to 2 times f of 0. Check this out, parentheses. I have typed that as y1, so I'm going to press alpha trace and it retrieves y1, and I want y1 at 0. Treat it like a function. Put parentheses. This will evaluate y1 at 0. And then I need y1 at 2, and I need y1 at 4. 43. This answer is 43. 43 what? Well, they said approximate the area. So this area that I shaded right here in this blue, orange, and green little rectangles is 43 square units. So question for you, is that too much? Is it too, not only is it too much work, but is it, did I accurately estimate the area here, like exactly under this curve. Let me show you exactly what I'm talking about. What I'm really finding, and I just want to give you a visual for it, is finding the area from 0 to 6. I want to know that exact area right there. Okay, that's what we're dealing with. In case you care, the exact answer is 39. You're going to figure that out later in a different lesson. But if I wanted to know that exact area, and I got 43, I got too much. And I don't just know that because I know the exact answer, because this used a little bit of funky calculus to get there that we'll eventually get to. But I colored too much. Like, I colored outside the lines of what I was supposed to be coloring, and therefore this answer is an overestimate. I'm just saying, okay? Let's hold that thought. Let's move on to a right-hand sum. And same idea, this one will go a little bit faster. We're going to start by realizing that we're dealing with, well, 6 and 2 and 4. Probably should have put those numbers on the last one, 2, 4, and 6. But we're dealing with those. But now that we're dealing with a right-hand sum, I'm not going to be like, let's start here. No, let's start here. Put your right hand down. Let's start here at 6. And I will use green as my beginning one. It's going to go at the end, though. I will start at 6 and go up until I hit the function. And then my width is 2 because 6, 0 to 6 is 6 units wide. Divided by 3 is going to give me 2. So we're going to go up to f of 6 and then back up 2 and then go down. And we have that right there. Okay? Well, what's that? That is 2 f of 6. Let's switch colors. That was positive. Let's go to the next one, which I will let be red. So we're moving on until we reach the end of this interval that we're dealing with. So we go to 4. We go up until we hit the function. And we come over 2 units in this case. And we'll color this one orange. So this is our red and orange. It's orange. 2 f of what? Okay, the height of this rectangle was determined by the value of the function at x equals 4. So there's that one. All right, next one. We go over to 2. Last one, we go up till we hit the function, and then we move over. And that's the end of it. That's the end of it because in moving over, we reached 0, which was the end point of an interval. And we will color this one blue or not. You can color it or not. It's up to you. What excellent shading I have done. Oh, wonderful. It's disgusting. 2 f of 2. There we go. So what I'm going to do now is look at this and say, well, I can factor a 2 out, which I think is fairly obvious. So this is equal to 2, and then f of 2, f of 4, f of 6, and then we'll figure this answer out as well. So we actually just did this on this problem, and the only difference was that that was a 2, that was a 4, and that was a 6. Let me show you a calculator hint. If you press second and enter, it pulls up the last thing you typed. And I can change that to a 2, 4, and 6. That won't be necessary. Change that one to a 6. Question, before I press enter, is this answer going to be less than, equal to, or greater than that answer? Did I shade less area, or more area, or the same area? I think I shaded less. I shaded 34 square units. Okay. Is that an over or underestimate of the exact area, which we found a minute ago using tools that I have not yet shown you? Whoops, that's not it. That's not it at all. No. The exact area is 39, using stuff that you'll learn one day soon. Clearly an underestimate, and I think it's obvious because in this case, we colored too much. In this case, we didn't color enough. All right, one more. Same idea, even faster. 6, 4, 2. What's the third one? a midpoint Riemann sum. Riemann was a brilliant man. Riemann made some things that to this day people still haven't completely figured out. It's called the Riemann hypothesis. And as of the filming of this video in September of 2023, people still haven't figured it out. Brilliant stuff. Okay, midpoint doesn't mean I'm gonna come from the left or come from the right. I'm actually gonna pick my rectangle and go to the middle of it, which in this case, from 0 to 2 would be 1, or from 2 to 4 would be 3, or from 4 to 6 would be 5. And the height of each rectangle is based on the middle of the rectangle. So I'll go ahead and give you a little indication. This one right here, we stop there. This, the midpoint sum, is not always obvious if it's an over or under estimate. Sometimes you can tell by looking at it, sometimes you can't. Not one of the more obvious ones. There's that. Okay. That would be our first rectangle, known as the blue rectangle, 2f of 1 plus 2f of what? Okay, where's our next rectangle coming from? Well, it's this width right here. And that's where that 2 comes from. That's the width of the rectangle. And the height of the rectangle is based on the middle of the rectangle, which happens at x equals 3. And we're going to color that orange. Red border, orange interior. And the height of this rectangle is whatever f of 3 is. And then, last one, green, 2f of, I hope you know it. I sure hope you know it. It's going to be this guy right here. 5. And we'll color it green. Green. There we go. And we'll figure it out. Overestimate, underestimate. I personally think it's a pretty good estimate. It's going to be closer to the actual value of 39, which of course you don't know how to do yet, but you will soon. I'm kicking things. Sorry, didn't mean to do that. So let's type that in, and if you care, you can do 2f of 1 plus f of 3 plus f of 5. If you have too many rectangles, that becomes cumbersome. There is a shortcut on the calculator that's not worth our trouble on this one. Second entry pulls up the last thing you typed, and we're going to go 1, 3. Whoa, that's not what I wanted. No, 1, 3, 5. You can go back and edit whatever you need to edit, which I just did. 1, 3, and 5. And the answer is not that. I was wrong. The answer is 39.25. With the midpoint sum, the real answer, the actual answer, is 39. So this one's a very good approximation. Well, yeah, almost said something that would have been mathematically inaccurate, so I'm not going to do that. 39.25 square units. We now have a strategy for finding area. Why do we need to find area under a curve? Glad you asked. So we can find quantity. Remember this lesson? So we can find the distance that we traveled. So we can find out how much water is in the tub. So we can find out how much air is in a terrifying balloon. That's why we needed this. So we can find that area. If there is a way to do it exactly, why do we have to learn this strategy? Because, you know, there is that way that the calculator does it exactly, and you can learn it by hand as well for most problems, or some problems. Why do we do this? Because we don't always have a function. Sometimes we have to use a table. All right, you'll see more in the next video.